Feeling like your AP Chemistry teacher might be a little bit extra? Let's find out just how extra they are. These are some of the topics that some teachers choose to cover, even though they're not a part of College Board's curriculum. First up, the history of atomic theory. You probably spent entirely too much time on this in Chem 1, but guess what? It is not included in College Board's curriculum. So if you are still going over all of these discoveries towards our ideas of the atom, I'm sorry, you're not going to see it again. Next up is going to be nuclear chemistry. It kind of relates to atomic theory and whatnot. So it's actually not included in the CED at all. So no nuclear fission versus fusion, any of those decay equations. It's really fun to learn about nuclear chem. Believe me, I'm from Oak Ridge, Tennessee. I'm very interested in it. But, College Board doesn't think it's valuable. So if you're learning this in class, well, it's extra. What about half-life? You actually aren't going to spend time with radioactivity, but you might see half-life listed as a great example of first-order kinetics, so keep an eye out for that in Unit 5. Next up is electron affinity. Now, you will have to answer questions about electron affinity. However, you will never have to predict electron affinity because, well, this is one of those trends that's not even really a trend. As you can see here, there are all kinds of exceptions, things that are out of order. What you do need to know about electron affinity is you need to be able to give the definition of it, and you need to understand that a positive electron affinity indicates an endothermic, unfavorable process versus a negative electron affinity indicates a favorable exothermic reaction. So that's the gist of what you need to know with this, but you don't need to be able to predict the electron affinities. You might have to describe, you might be given two electron affinities and have to explain why one is higher or lower than the other, but you won't have to make predictions about that. The Rydberg equation, something that's typically taught in physics, but you'll definitely see it in Gen Chem at the undergraduate level, but College Board does not think that you need to know this. When would you have to learn this? So this is just a formula we use to calculate the wavelength of light emitted during an electronic transition. So let's say it's typically used for hydrogen. It works best for hydrogen and smaller atoms, but we use that, we look at the transitions. Let's say we're going from n equals 6 down to n equals 5. We can use this to then calculate the wavelength of light that is given off from that transition. Next up, quantum numbers. Now, I will say knowing quantum numbers can help with electron configuration, but it's not going to be something that you're tested on. So these are the quantum numbers. We have N, L, M sub L, and M sub S. You can use this chart. You can save this if you've had to learn these in class. I linked this directly in the slide notes so you have access to it. It's basically just ways that we again, assign those locations or addresses for the electrons. So each electron is going to have its own unique set of 4 of these quantum numbers that specifically describe where we think we will find it. This next one is one that is often taught in AP Chemistry, even though you won't be tested on it.
This is the Born-Haber cycle,
a way to calculate the lattice energy of an ionic compound. So actually figuring out how much energy is required to form that ionic lattice from its constituent elements. So let's say I'm building that lattice of sodium chloride. We are ionizing sodium. We are going through that whole process and adding everything together. So basically, if you're doing this process, you're getting some practice with Hess's law, which will be something that you have to know this year. So it's not like everything that you're learning that's extra isn't going to help you out. This will help you out as you understand the puzzle that is Hess's law. All right, and the last one, functional groups. So you will not have to know the functional groups in AP Chemistry. You will in AP Biology for the first unit, Chemistry Life, if you have that coming up next year. And you will absolutely need to know the functional groups for organic chemistry. Why do some teachers share these? It's because of IR spectroscopy. So you have to know that IR spectroscopy is going to probe molecules using IR radiation, right, infrared, and that's going to give us indications about the vibrational energy or the energy from stretching and bending those bonds. So as you can see here, we're going to have different regions, and we can look at this IR spectrum and actually identify that this is going to have an OH bond, and we can just look at all of these peaks. But guess what? You don't have to know how to interpret IR specs in Gen Chem. You don't have to learn how to do this until you take organic chemistry. And I promise you're going to spend hours agonizing over these, learning all of these functional groups. Just make a set of flashcards, memorize them. You'll notice them as you look at different problems and things like that, especially as we get into intermolecular forces. However, you will not be tested on whether or not you remember the difference between alkenes and ketones. So yeah, your teacher might be extra, but You should thank them for it because it means that you are going to be extra prepared for your next chemistry class, whether that's Gen Chem or organic chemistry. You're going to have a better background than what's just covered in the standard AP course. Thanks for watching. I hope this was helpful. Please leave a comment if you have suggestions for my next video.